And since it's distance, it's always positive. Okay, because it doesn't matter what direction you go, or if you're walking forward or backwards. If you're going 5 feet, you went 5 feet. You didn't go negative 5 feet just because you walked it backwards, right? So distance is always positive. So absolute value is always positive. So anytime you see two straight lines with something in between them, that's the absolute value. So this is the absolute value of 2. And because it's always positive, the absolute value of a positive number is positive, and the absolute value of a negative number is positive. So to simplify expressions with absolute value is kind of like parentheses, so you need to do what's inside the absolute value first. So what we do is we do 3 minus 8, that's negative 5. Then you take the absolute value of the number, and since it's always positive, it'll be positive 5. And then you multiply. 2 times 5 is 10. Okay. 2 minus 9 is negative 7. Absolute value of negative 7 is positive 7. 4 times 7 is 28. 3 plus 5 is 8. The absolute value of 8 is 8. Times negative 5 is negative 40. 9 minus 7 is 2, and 3 minus 8 is negative 5. Absolute value of 2 is 2. The absolute value of negative 5 is positive 5. 4 times 2 is 8. Plus 5 is 13. Here I have 7 minus negative 2. Minus and negative is always positive. So I get 6 times the absolute value of 9 plus the absolute value of negative 5. So that's 6 times 9 plus 5. So that's 54 plus 5, so 59. Now you'll notice the only time we got a negative number was when we had a negative number outside that multiplied. Every other instance of absolute value was positive. So the only way you're going to get negative with absolute value is if you have a negative outside that gets multiplied by the absolute value after you take it. Value is always positive. Here's what happens. If I have a 7 and I take the absolute value of it, I get 7. And if I have a negative 7 that I take the absolute value of, I also get 7. So then if I say, well, absolute value of x equals 7, it could be either 7 or negative 7, right? Because if I plug a 7 in here, I get 7. If I plug negative 7 in here, I also get 7. So when you have absolute value with variables, you're going to get 2 answers. Okay? So if I ask you the absolute value of x is 2, that means x is 2 or negative 2. Because both of these would make this true. Now what you want to do when you have absolute value equations, you want to treat this absolute value of x just like a regular x when you're trying to do the solving. Okay, and we want to get that x by itself. So we want to get the absolute value of x by itself. So the steps that you take are going to be the same as if you were solving this. So my first step is it going to be to subtract 5 from both sides. So you get 4 times the absolute value of x equals 8. Okay. My next step is going to be then to divide by 4. So I get the absolute value of x is equal to 2. Now I have the absolute value of x is equal to 2, so what does x equal? X is 2 or negative 2. Because if I put absolute value of 2, I get 2, over the absolute value of negative 2, I also get 2. Okay. Now absolute value is always positive. So this box over here, very important. If you have a situation where you get absolute value equals negative, like this, there's no solution. So if I set the absolute value of x equals negative 10, no solution, because absolute value can't be negative. Right, so again, we're going to treat it the same for solving steps as this. So I'm going to subtract 4 from both sides, and I get 2 times the absolute value of x equals 14. Divide by 2, and I get the absolute value of x is equal to 7. And then that's when I get the 2 answers. 7 or negative 7. Right. So subtract 4. And then divide by 2. So your absolute value of x equals 4. So that means x equals 4 or negative 4. Always positive and negative of that number. Okay. Subtract 8 from both sides, and I get negative 3 times the absolute value of x is equal to negative 9. And I know I said the absolute value can't be negative, but we're not to the absolute value equals negative yet, so we have to get the absolute value completely by itself before we make that judgment. So we have the absolute value of x is equal to positive 3. So see, this is now okay. So x equals 3 or negative 3. I have 4 times the absolute value of x plus 9, so if I subtract 9, I get 4 times the absolute value of x equals negative 17. And then if I divide by 4, I get the absolute value of x is equal to negative 17 fourths. This is not possible. So there's no solution. And the reason there's no solution is because this is negative. Add 5 to both sides. Divide by 5. And then split. Now in these problems, the problems that we're going to be doing right now, you will either have 2 answers or you will have no answer. So 2 or none. There's only 2 cases where you could end up with 1 answer with absolute value, and one of them we're not going to be working on right now. And the other one is this. The absolute value of x equals 0 means x equals 0, because I can't say x equals 0 and negative 0, right? There's no such thing. So this is a special kind of an exception to where you have one answer. But otherwise, when you solve these, you get 2 or no answers. For now. X is not by itself inside the absolute value. Okay, so when that happens, we need to get the absolute value, so this portion by itself, we want to isolate it. Okay, so I'm going to subtract 5 from both sides to get the absolute value alone. And once I have that alone, whatever is in the absolute value, if I plug a 16 in here, it would be 16. If I plug negative 16 in here, it would still be 16. So now what I have to do is I have to split the equation. Okay. So my first one is 2x minus 8 equals 16. My second one is 2x minus 8 equals negative 16. And then I solve each of them individually. So I add 8 to both sides, and that gives me 2x equals 24. Divide by 2, and I get x equals 12. Come back over here, add 8 to both sides, and I get 2x equals negative 18. Divide by 2. Sorry, not negative 18. Negative 8. And then I get x equals negative 4. So my solutions, I have 2 of them. I have x equals 12 or negative 4. Except this time to isolate, we don't have anything to add or subtract, we're going to divide. So I'm going to divide by 2. And I get the absolute value of 2x plus 4 equals 10. And then I split. And I subtract 4 from both sides. And then divide by 2. And I come over here and I subtract 4 from both sides. Then I divide by 2. So my solution is x equals 3 or negative 7. I'm going to split this. And again, the only difference between them is that one of them is equal to positive, the other one's equal to negative. Subtract 6 from both sides. 3x equals 6. Divide by 3. X equals 2. Subtract 6 from both sides. 3x equals negative 18. Divide by 3. X equals negative 6. So my 2 answers. And I'm sure you'll notice that I'm doing the same steps on both problems. Minus 6, divide by 3. It's just the difference is here, what happens here. Now, if you would like, you can do a different setup. I know. Instead of doing 2x, or sorry, yeah, here, let's say this. 2x minus 3 equals 10 or 2x minus 3 equals negative 10. You can string it together if you want. You don't have to. Like that. It's less writing. And the reason we do that is because, like I said, as you can see, we do the exact same steps to both equations. So when you do this, if I'm adding 3 here, I have to add 3 here and here. So 3 places instead of 2. So it gives me 2x equals 13 or negative 7. And then I have to divide by 2, divide by 2, divide by 2. So we get x equals 13 halves or negative 7 halves. Okay, C is really hard. The absolute value of 5x minus 1 equals negative 8. No, it doesn't. Because absolute value is never negative. So anytime you see that, no solution. Now here I have a negative 24, but see I have this negative out front and that negative right there. And so I'm essentially going to divide by negative 1, or I'm just going to change both signs. Because they're both negative, so I can change them to both being positive because basically, like I said, I'm dividing by negative 1. You don't have to write that step in though if you don't want to. Then I can split it. Or again, you can run it together and just say 24 or negative 24. Add 8 to both sides, or all 3 sides, depending on how you're doing it. And you get 4x equals 32 or negative 16. Divide by 4 and you get x equals 8 or negative 4. Okay, a ratio is a comparison of 2 values. Okay. They can be written in 3 ways. Right now in this class, I have 1 boy and 2 girls, right? So I can say I have a 1-to-2 ratio, 1 boy, 2 girls. I can say I have a 1-to-2 ratio using a colon, or I can have a 1-to-2 ratio using a fraction. These all tell me the exact same thing. Okay. And this is the ratio of boys to girls. And the first number is boys, and the second one has to be girls. If I said the ratio of girls to boys, I'd have to say 2-to-1 instead.
Oh, just like ounces and weight is also a ratio.
Mm-hmm.
Nonsense and everything.
Yes, exactly. Okay, now a proportion. Say okay, ratio is a comparison of 2 values. A proportion is a comparison of 2 ratios. And the comparison is that they're equivalent. which means they're equal. So examples of proportions. This is a proportion. This is a ratio 2 to 3 is equivalent to 4 to 6. Right? Because if I take them as fractions, I can do this also. We don't usually use
Rising the denominator, not in the numerator.
We don't usually use proportions in this format, but we can in this format. So I could say 2 to 3 is equal to 4 to 6. That we have is we look at this. Okay, to turn a 2 into a 16 and multiply by 8. To turn a 3 into a 24, I also multiply by 8. If these two numbers match, this is a proportion. And I can say these two things are equal. Okay. To turn a 6 into a 2, I divide by 3. To turn a 10 into a 5, I divide by 2. These two numbers don't match. So they're not a proportion. They're not equal, so I can put the symbol for not equal in between them, which is like an equal sign with a slash in it. Okay. 1 to 5, I multiply by 5. 6 to 30, I multiply by 5. That's good. These are a proportion. They are equal. The 0.2 to 1.2, 1.5 to 9.0, it's not always easy to just figure out what to multiply by because we have odd numbers. So we can use the parts of a proportion. If you have a proportion set up, the two middle numbers are the means. Those are also, oops, sorry, that's wrong. These two numbers. Okay, the two outside numbers are called the extremes. That is these two numbers. Okay. Now, in a proportion, the product of the means is equal to the product of the extremes. That means if I multiply the two means together, it has to equal the same as the two extremes. So looking at this, I say 3 times 16 has to equal 2 times 24 for this to be a true proportion. That's 48. This is 48. So it works. Method 2 on how to tell if a pair of ratios is a true proportion. We're going to cross multiply. Okay, so I'm going to do 2 times 14 and 3.5 times 8. 2 times 14 is 28. Actually, 3.5 times 8 is 28. These are equal, so it is a proportion. Okay. I'm going to cross multiply, and I'm going to get 0.3 times 2.0 and 1.5 times 0.5. I think that's going to be 6. So that's 0.6, and this is 0.75. These are not equal, so not a proportion. And again, this had decimals in there. It's not so easy to say, okay, well, what do I need to multiply to turn a 0.3 into a 0.5? Or what do I need to divide by? Or, it's not that easy to do. So you can cross multiply, and that makes it much simpler. I'm going to cross multiply, and I'm going to have x times 5, that's 5x, equals 30. Then I'll divide by 5.
6.
So x will be 6. We do the same thing here, even though it looks a little weird. I have x minus 2 times 7, so in this particular instance, if this happens, you're going to have to distribute. And then 14 times 2 is 28. I have to distribute that 7. So I get 7x minus 14 is equal to 28. Add 14 to both sides. 7x is equal to 42. Divide by 7. And x equals 6. You can use proportions to solve these too. What you want to be really careful of. Okay, so you have some type of number, right? I can't write type. And if I set them up, whatever number is type 1 and I put it over type 2, what I really need to be careful of is when I do the other side, I have type 1 over top of type 2. Okay, so the same type of number needs to be on the top on both sides and the bottom on both sides. You can't say type 1, type 2, and then come over here and put type 2 on top. Does that make sense? Because then that's no longer proportional. So what we have is, in the past 2 years, a retailer has opened 232 stores. If this rate remains constant, how many stores will the retailer open in the next 3 years? So my types are years and stores. These are my types. Okay. So what I have is 2 years and 232 stores go together, right? And I have 3 years with some unknown number of stores. So I'm going to set up a proportion for this. The two that go together, the 2 years and the 232 stores, I'm going to put the 2 on top just because it looks prettier to me. But you could easily put the 232 on top. It doesn't matter. Okay? So now when I come over here, if the 2, which is years, is on top on this side, years has to be on top on that side. Make sense? I don't know how many
The
stores.
ratio.
Yeah.
The ratio goes with each other side by side.
Exactly,
On the top,
yeah.
on the bottom.
Exactly. What letter you guys want to use? Huh?
R.
R? Okay, sure. We'll use R. So then I'm going to do 2 times R and 3 times 232. So I get 2R is equal to 696. And then I divide by 2. And I get R is equal to 348 stores. Scale is a ratio of sizes. Okay. In which you can shrink or enlarge. You're more used to scale on certain scale models. Scale models are physical representations of scale. And they're the reason we use scale. Because if you think about a road map, right? You guys have all seen the road map where it has like the little thing at the end that says like 1 inch is 100 miles. That's the scale. Where 1 inch is 100 miles is the scale. So 1 inch equals 100 miles is an example of scale. Well, the scale model is the map. Because it's using the scale, because if you didn't put a map to scale, you could never carry it around with you, right? It would be the same size as the whole world. Not practical. Other things that are scale models, you get models of buildings. You know, when you see the architects make a building that looks like the building that they're going to build to present it to try to get the funding or whatever. Well, they can't make the whole building and then try to get the funding. They have to make a scale model, but they make it to scale so that people can see what the real sizes and dimensions are going to be. People that are really into model cars or model trains, those are to scale. The other thing that you probably are really familiar with as being to scale is if you have taken any science class and they have had a picture of a virus or a bacteria or a mountain that's to scale, like they take, you obviously, I've got a gazillion bacteria like on me now, we all do, right?
Yeah,
But you can't see them unless you blow it up. But it's blown up to scale, so.
the microscope and everything is in a way similar to that.
Yeah, exactly.
The resolution and everything.
Yeah, exactly. That's exactly how it is. So you guys are really used to scale, actually. And scale is a ratio, and we can solve them with proportions. So if we want to know, like we're going camping in the Great Smoky Mountain National Park this weekend, and 3 inches is equal to 10 miles on the map. And there's this trail that's called the Ramsey Cascades Trail, and it's 1 1/8 inches on the map. We measured it, and the only has 1 H in it. Okay. We want to know how far is that trail. Do we really want to walk this trail or not? I mean, when I look at it, it's only 1 inch. No problem. Done. No, because it's to scale, right? So we want to find out. So we're going to put inches over miles is equal to inches over some unknown amount of miles. Let's use m for miles. I don't want to multiply 1 1/8. So I'm going to convert that to a fraction by doing 1 divided by 8. Or sorry, convert to a decimal. So instead I'm going to do 3 over 10 is equal to 1.125 over m. I'm going to multiply, so I'm going to get 3m is equal to 11.25, and I'm going to divide both sides by 3. And I'm going to get that my miles are 3.75, so almost 4 miles. So then you can decide if you really want to walk that far or not.